Today we're going to look at scientific notation. Numbers written using scientific notation are expressed in this form here, a times 10 to the power of m. So we've got a number here, times 10 to the power of m. A is between 1 and 10. It can include 1, but does not include 10. So it's all the way from 1 up to 9.9999999. And m is an integer, so m can be negative or positive or 0. The reason why this is a really useful way to express numbers is if we've got really large or really small numbers, there'd be lots and lots of decimal places, and this is a much more compact, easier, simpler way to be able to express it. For example, if we've got the hydrogen atom here, the hydrogen atom, if we're looking at how large it is in diameter, it's about 1.6 times 10 to the negative 12 metres. So that would be 1, 2, 3. If we were expressing that using decimal notation, so many zeros. So it's very difficult to, if you were writing a scientific paper and you needed to use that or make calculations with that, much more compact, much easier to just write the 1.6 times 10 to the negative 12. Similarly with the Milky Way galaxy, it's 9.5 times 10 to the 20 metres across. Huge distance, hugely large distance. So it's 9.5 and then we'd have another 19 zeros. It would be just a pain to write out all the time, so it's a much more compact way of writing. So in order to convert to scientific notation, we need to shift the decimal point until the number is in between 1 and 10. So here, for 38 million, we've got the decimal points after the last 0, so we shifted all the way up until we got to 3.8. That number that we get, that 3.8, that is going to be our value for A. The value for M is going to be the number of decimal places we shifted to the left. So if we're shifting to the left, 1, 2, 3, 4, 5, 6, 7, then our value for M is going to be 7. If we're shifting in the opposite direction, so for example, if we were looking at 0.006067, we'd shift the decimal point, but this time we're shifting it to the right. 1, 2, 3 to get it in between 1 and 10, so that would be 6.7, and we've shifted it 1, 2, 3 to the right, so it's going to be negative 3 because we've shifted it in the opposite direction. So if we had a look at some examples, writing the following in scientific notation and then expressing the following scientific notation in decimal form. If we look at 4,500,000, the decimal point is here, and if we shift it 1, 2, 3, 4, 5, 6 to the left, we get 4.5, that's our value for A, and we've shifted it 6, so it's times 10 to the power of 6. For our decimal here, 1, 2, 3, 4, 5, 6, 7 rather, to get it in between 1 and 10. So we've got 4, and that'll be 4 times 10 to the negative 7 because we've shifted it 7 places to the right. If we're looking at expressing 9.34 times 10 to the power of 5 in scientific notation, the decimal point 9.34, so it's times 10 to the 5. We're going to be shifting that decimal point 5 places to the right. 1, 2, 3, 4, 5. So we get 934,000 there. And for our value here, 4.71 times 10 to the negative 5. Decimal point is here, 4.71, and we're shifting it 5 places to the left. 1, 2, 3, 4, 5. And so we get 0.0000471.